Hi friends, yesterday we introduced the concept of logarithm. Today we are going to look at the laws of logarithm. And the first law of logarithm is what I call the validity law. And the validity law states that the logarithm of a number can only make sense when that number is greater than zero. And numbers greater than zero are positive numbers. Numbers less than zero are negative numbers. So this law is trying to tell us that the logarithm of a negative number does not exist. So if we have log A base B, this logarithm can only exist if only A is greater than zero. That means A must be a positive number. So if A is a negative number, the logarithm does not exist. This is the first law. Now the second law is called the addition law. And the addition law of logarithm states that when two or more logarithms on the same base are added, then the result is the logarithm of the product of the numbers to the common base. So log A base B plus log C base B says that the result is equal to log A times C all to base B. So this law is trying to let us know that when you have something like log 2 base 3 plus log 5 base 3, the result is equal to log 10 base 3. That's what this law is trying to let us know. Now, the third law is what we call the subtraction law. And the subtraction law states that when two or more logarithms on the same base are subtracted, then the result is the quotient of the logarithms to the common base. So you have log A base B minus log C base B is equal to log A over C all to base B. Remember that the second law and the third law are only valid when the bases are the same. If the bases are not the same, please don't apply these laws. Now, the fourth law is what we call the power law. And the power law states that when a logarithm is raised to a certain power, then the power is used to multiply the logarithm itself. So log A raised to power C base B. This is equal to this C will now move down to multiply the logarithm. Becomes C log A base B. In other words, when you have something like log 3 squared base 4, the result is equal to 2 log 3 base 4. That is what we call the power law. The fifth law is what we call the power of the base. If it is the base that has the power, then the reciprocal of that power is used to multiply the logarithm itself. So when you have log A base B raised to power C, when it is the base that has the power, then the reciprocal of that power will be used to multiply the logarithm. In other words, when you have something like log 3 base 4 raised to power 2, now the result is the reciprocal of 1 over 2. That's the reciprocal of 2. 1 over 2 will be used to multiply the logarithm itself. Alright, that is the fifth law. And the sixth law is logarithm to the same base. The logarithm of any number to its own base is equal to 1, no matter what that number is. So the logarithm of any number to its own base is equal to 1. In other words, log 10 base 10 is equal to 1. And also, log 2 base 2 is equal to 1. The log of a number to its own base is equal to 1. Now, the seventh law we're going to look at is the logarithm of 1 to any base. And that law says that the log of 1 to any given base is equal to 0. No matter what that base is, the log of 1 to any given base is equal to 0. So you have log 1 to any given base. Let's call that base B. The result is equal to 0. In other words, log 1 base 100 is equal to 0. So this law implies that if I promise to give you like log 1 base 5 million naira, you may be jumping up and down thinking that you are now a millionaire. But it is only a comrade that will understand that you are getting nothing from me. So that's what it means. Log 1 to any given base is equal to 0. Now, the eighth law is what we call the reciprocal law. And the reciprocal law tells us that when the reciprocal of a logarithm is required, then the number and the base will interchange their positions. So it means that log A base B is the same thing as 1 over log B base A. So this law tries to tell us that if log A base B is equal to C, then log B base A is equal to 1 over C. When the reciprocal of a logarithm is required, then the number and the base will interchange their positions. In other words, we know very well that log 8 base 2, we know that the result is 3. So if we change the positions of the number and the base, then log 2 base 8 will now give us 1 over 3. That is what we call the reciprocal law. Now, the ninth law of logarithm is what we call change of the base. And that law states that when the base of a logarithm is to be changed to a new base, then the logarithm of that number to the new base must be divided by the logarithm of the former base to the new base. In other words, if log A base B is to be changed to another base, say C, then it becomes log A to that new base C must be divided by the logarithm of the former base to the new base, that is C. So, in other words, if we have something like log 8 base 2, we want to change this base 2 to base 4, then the result will now be equal to log 8 base 4 divided by log 2 base 4. Because if you evaluate this, it's still going to give you this. So that is the ninth law. And the 10th law of logarithm is the Kruficid law. And the Kruficid law states that when a number is raised to the logarithm of another number to the base of that same number, then the result is equal to the other number. So when you have the number n is raised to the logarithm of another number x to the base of that number n, it says that the answer is the number x. So when you have something like 2 raised to power log 4 is 2, it says that the result is equal to 4. So these are the 10 laws of logarithm. We're going to engage these 10 laws of logarithm to solve practical examples in our next lecture.